In this video, we're going to look at 3 examples of how can I combine like terms to simplify an expression. So we're going to go over 3 more examples looking at how we can answer that question, how to combine like terms and simplifying expressions. These expressions become decently complicated in here. So our first expression we'll look at says 3y minus 2x minus 3y plus 7x. So you look at your like terms and you say, okay, well, I have a y term, I have a y term, and I have an x term and an x term, and that's it. There's no constants. So we look at that first. We know we're going to want to combine the x terms and combine the y terms. There's nothing to distribute around here. We just have to deal with these subtraction symbols. So I'm going to first deal with those by simply making them addition. 3y plus negative 2x plus negative 3y. Again, I just add the opposite plus 7x. And now I have subtraction, that's addition. Now I can order these any way I choose. So I'm going to reorder these so I can more so add the numbers I want. 3y plus negative 3y plus negative 2x plus 7x. Now, when I go to combine these, I see 3y and negative 3y. Well, those are the additive inverse of each other, so they're going to actually cancel out, and it will be 0. It'll be 0y, which is just 0, nothing. Bye-bye. And then I have negative 2x and 7x, and I know it's going to be an x, and then when I add negative 2 and 7, that's really subtracting 7 minus 5, because I'm going to take the difference of their absolute values. The absolute value of negative 2 equals 2, and the absolute value of 7 equals 7. 7 is greater than 2, or 7 is greater than 2. So I wrote that down wrong over there. So do 7 minus 2, it equals 5. And I know since 7 had the greater absolute value, that originally was positive, so my answer is 5x plus 0, which can just be written as 5x. This expression is simplified as just 5x. This next example I want to go over has some terms that we haven't seen before. You have 7y cubed plus 3x minus 7y squared minus 3y cubed minus x. So what you see is you have exponents along with variables, and when there's an exponent along with a variable, it's considered a separate term. So like 7y cubed is a common term with 2y cubed. So those are the same term. However, the term minus 7y squared, that is a different term, and we cannot combine that with the y cubes. Just like the x's are separate terms in themselves, and those can be combined together. The first thing I would do in solving this problem is I would change all your subtraction to addition, so I can then reorder and combine like terms a little bit easier. So 7y cubed plus 3x plus negative 7y squared plus negative 2y cubed. Oops, a lot of space there. Plus negative x. Now I can reorder these any way I want, and so the first thing I'm going to do is combine your y cubes. So you have 7y cubed and negative 2y cubed. It's actually the same problem we just solved. 7 combined with negative 2. The y cubed stays the same. And I know that when I look at this one and I come on over here, I'll do my work to the side here. I'm doing 7 plus negative 2. And then the absolute value of 7 equals 7, and the absolute value of negative 2 equals 2. I find the difference between the two of these since they have different signs. 7 minus 2 is 5. Since 7 had the greater absolute value, that originally was positive, so my answer is going to be positive 5y cubed. The next thing I'm going to combine are going to be my x's. I have 3x and negative x. And that's really a negative 1x when I think about it. So 3 plus negative 1. I'm going to come back over here and add those integers, knowing that it's going to be plus some x. We haven't figured that out yet. So I come over here, 3 plus negative 1. 3 plus negative 1. Well, the absolute value of 3 equals 3. The absolute value of negative 1 equals 1. I'm going to find the difference between the two of these since they are adding two integers with opposite signs. 3 minus 1 equals 2. 3 has the greater absolute value. 3 was originally positive, so I'm going to keep it a positive 2. This is going to be plus 2x. Now, I've combined all my like terms, and I'm left with a plus negative 7y squared. In terms of how you usually write an expression, you usually like to start an expression with your highest degree of a variable, and by highest degree, I mean like the one with the largest exponent. So if I were to write this properly, I would write it 5y cubed, because that's my largest exponent. And then instead of writing plus, I'm going to go ahead and change this back to subtraction. Minus 7y squared plus 2x. And at that point, I have combined all my like terms and simplified this expression as far as it goes. This next expression is 9x plus 6y plus 12y plus 16x divided by 4. So the first thing you want to do here is distribute. Since I don't have any subtraction, I'm going to first want to distribute this 4 up amongst the y and the x there. So I do 9x plus 6y plus 12 divided by 4y plus 16 divided by 4x. And these all work out nicely, which is convenient. 12 divided by 4 is 3y. 16 divided by 4 is 4x. So this problem is going to turn out to be pretty simple, since I don't have to deal with any subtraction changes or anything like that, and no squares or anything, or cubed. 9x plus 6y plus 3y plus 4x. So let's look at my like terms. I have x, and those are both positives. 9 plus 4, traditionally adding them, would be 13x, plus my y's, y and y. 6 plus 3, both are positives, so I'm just traditionally adding them. 6 plus 3 is 9, 9y. 13x plus 9y is how you would simplify that expression. Again, these are 3 different ways, 3 different problems. Hopefully these examples, now you can better answer the question, how can I combine like terms to simplify an expression?